Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is week 9, the last week of classes in term 1B. So of course that means that you need to finish up whatever you're working on, finish up your key questions and submit them for marking as soon as possible if you want to finish this term. Next week is our turnaround week or admin week. So you can still submit work in that week to finish up. But if you don't finish by the end of next week, by the end of this week or next week, you can continue working on your key questions and continue to submit them to your teacher in term 2B. PLAR students are not withdrawn at the end of the term, so keep that in mind. You can participate in classes via radio or Zoom, and the instructions are in your study guide. All PLAR Math students are welcome to attend classes, so you don't have to be signed up for Radio Zoom. Even if you sign up for IL, you're still welcome to join the classes. To contact me, you can use email, phone, or send a message on Facebook, whatever is more convenient for you. And the PLAR English classes from last term are still available on YouTube. So you can go to either my YouTube channel, B. Osmond Wasa YouTube, or you can go to the WASA Distance Education Center channel and you can find the classes there. Also, the PLAR Math classes from this term are recorded and uploaded to YouTube, so you can find those classes there as well. And those classes will stay there into next term, so you can still go and watch those classes on YouTube. As I mentioned, students who do not finish this term can continue working on your key questions in term 2A. We're offering students this year the option of writing the culminating activity instead of doing the lessons and key questions. So if you want to try writing the culminating activity first, instead of doing the lessons and the key questions, you can do that. If you pass the culminating activity, then you get all of your missing credits, or your missing English or math credits, whatever subject it is. And you don't have to do the lessons and the key questions, and you can just move on to the next subject. However, if you're not successful with the culminating activity, then you do have to go through the lessons and complete the key questions. Then once you finish that, then you write another culminating activity once you've successfully passed all 5 of the lessons. So you do get a second chance to write the culminating. So next week, the week after, in 2 weeks, we will be starting term 2A. So beginning on February 3rd. So in term 2A, for PLAR, it will be the PLAR English and the PLAR History Geography. And the classes will be same as this term from 10 to 11. On Mondays and Wednesdays will be the PLAR English, and the PLAR History Geography will be Tuesdays and Thursdays. So keep that in mind if you're working on that next term. If you are working through the lessons, you will notice that there are 2 types of questions in the lessons. There are support questions and key questions. You do the support questions first. The support questions are the practice questions that you do before you do the key questions. So as you go through the lesson, there will be an explanation of how to do something, and then you will see support questions. The answers to the support questions are near the end of the lesson, right before the key questions. So do the support questions, then go check your answers at the end. If you are doing well with the support questions, then you move on to the key questions. The key questions are the only questions that you submit to me for marking. They have marks for them. The support questions do not. So once you've done the key questions, then you submit those to me for marking. And you should start working on them as soon as you can and submit them as you do them. Don't wait until you finish everything before you submit your key questions. Ways to submit your work, there are several. First of all is to give it to your DEC, and then your DEC will send it out to us here in Sioux Lookout. If you don't have a learning center or DEC, or your learning center is closed, your DEC may be away or whatever, If that's the case, then you can submit your own work. If you are submitting your own work, be sure to write your name on your paper, okay? Because if you're sending it out, if you're emailing it to me, then I know who's emailing it. But if you're emailing it to student work, somebody else might not know who it's from, okay? Or if you're sending it via messenger or something like that. So make sure that your name is on your work. You can also include the subject and your teacher's name as well, and that helps even more to figure out who it's from and where it's going. Okay, so to submit your own work, first of all, you can scan and email your work if you have access to a scanner to studentwork@nnec.on.ca and CC it to me. Or if you have a fax machine, you can fax it to our toll-free fax number. If that doesn't work for you, then you can use your smartphone and either take photos of your work or scan your work using the built-in scanner on your phone, and then you can email it to that same address, studentwork@nnec.on.ca, and CC it to me, or you can send it via Facebook Messenger, okay, whichever one works better for you. If you are living in Sioux Lookout or the surrounding area and you come to Sioux Lookout fairly often, you can use our outdoor mailbox, which is located at the side of the building in the WASA parking lot, so the side of the building toward the post office. You will find a box attached to the wall, and you can drop your work in there, or you can knock on the front door and give it to whoever answers the door. You can also use Google Docs to do your work, and then you can send me the link so that I can get your work that way, or you can use Google Classroom. If you want to use Google Classroom, please call, email, or message me for the link and the codes. Just a reminder that at the end of Term 1B, so sometime next week most likely, we will be doing our student draws, end of term student draws. One draw is for students who earn a credit during the term, and one for students who submit work. So if you submit your work during Term 1B, your name goes in for every lesson, into the draw for every lesson that you submit. So if you submit all 5 lessons, your name goes into the draw 5 times. If you submit all 5 lessons and you get your credit, then you enter in 2 draws. So you have the opportunity to win 2 prizes. So make sure that you submit your work on time. And this is the last week of classes in Term 1B. So make sure you get your work finished and submit it. Okay, so let's get going for today. So we're going to start off with a review of what we covered last day. So on Thursday of last week, we were working, we finished up lesson 4. Today we're going to do our last lesson. So the last thing we looked at was graphing linear relations. So it's basically like solving an equation. So to graph a linear equation, first construct a table of values. So you can see a table of values here. This one is one example of how to construct a table of values. There are different types. Choose at least 3 values for x. So we have x values and y values when we're talking about linear relations, because we're graphing, so we need to have x and y coordinates. So what you're going to do is choose values for x. So what values do you want x to be equal to? It's always a good idea to choose smaller numbers so that you don't end up with a gigantic graph. So numbers like 1, 2, 3, 1, 0, and -1 are good numbers to use because they're small numbers. Or you could use 2, 1, 0 or 0, 1, 2, whatever you choose. So we'll put those in the chart under x. So those are our values for x. And then we're going to substitute those values into our equation. So here's our equation, y equals -2x minus 3. So the values we have in the chart, we are going to substitute those in for the x. Then once we're done that, then we will plot the ordered pairs that we come up with, our x and our y. and draw our line. Now, if the line ends up not being a straight line, then we will know that we have made a mistake in some of our calculations. So the line that you get when you graph or when you solve for a linear relation should always end up being straight. And as I mentioned, if it's not, then something is gone wrong somewhere. Okay, so let's solve for y when x equals 1. So just going to substitute that into the equation. So negative 2 times 1 minus 3. So negative 2 times 1 is negative 2 minus 3. And so y equals negative 2 plus negative 3, which is negative 5. So when x is 1, y is negative 5. Okay, now if x is 0, we have y equals negative 2 times 0 minus 3. Negative 2 times 0 equals 0 minus 3, so y equals negative 3. So when x is 0, y is negative 3. And then for negative 1, same equation, 2x times negative 1 minus 3. Negative 2 times negative 1 is positive 2 minus 3, so y equals negative 1. So when x is negative 1, y is negative 1. So now our x and our y values are x for our first one is 1 and y is negative 5. For the second one, when x is 0, y is negative 3. And for the third one, when x is negative 1, y is negative 1. Okay, so now we plot those on our graph. I'm going to go with a 2-page here so that we can see the full graph. Okay, so our first point is at 1 and negative 5, so I'm going to start at the origin, which is the middle, where the two axes intersect, and then I'm going to go to the right along the x-axis, positive 1, and down along the y-axis to negative 5. And there's my first point, 1 and negative 5. My second point is at 0 and negative 3, so again start at the origin for plotting points. 0 is my x-coordinate. I don't go left or right because I just stay at 0, and then it's negative 3 along the y-axis, so stay right on the y-axis. And then my next one is negative 1 and negative 1, so starting at the origin, go to the left of the origin to negative 1, and then down negative 1. Okay, and just from looking at that, I can see that my line is going to be, my line is going to be straight. Okay, so then I just draw my line, make sure that I have arrows on both ends. Moving the arrow, not the, there we go. Make sure I have arrows on both ends of my line, and there, it's kind of hard to line it up exactly, but that's pretty good. So my line goes straight through all 3 points. And it is a straight line. So if, for example, this one, move the dot instead of the line. Let's move this dot over here. So if this dot was over here, for example, it's supposed to be 0 and negative 3. So if I plotted it wrong and went, say, dot again, if I plotted it instead and did negative 3 and 0, then you can see that that dot is not in line with the other dots, so I did something wrong with that dot. So I'd have to figure out what I did wrong there. So all the dots should line up. All of the points on the Cartesian plane should line up and create a straight line. Again, if it doesn't, then you've done something wrong. Okay. So then the last thing that we looked at in lesson 4 was slope. So the slope of a line tells the steepness and the direction of the line. So we can have a negative slope or we can have a positive slope. And there are two ways of finding the slope of a line. So you can do it with a graph. So when you have your graph and you have your line on your graph, you can just basically count how far it is from point A, which is the dot on the left, to point B, which is the dot on the right. So to do that, we start at our left point A, and slope is equal to rise over run. So the rise is how far up or down from the first point to the second point, and the run is how far to the right. How far do you have to go to the right to get to the second point? So the rise for this line is 1, 2, 3, 4, 5, 6. We count how many units. So our slope is 6 over, now, first of all, sorry, we went from point A to point B, and to go from point A to point B, we had to go down. So when we go down, that means it's a negative slope. So it's negative 6. And then from point A over to point B, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So our slope is negative 6/9, and that's a fraction, so we can reduce it to negative 1/3. So our slope is negative 1/3. And as I mentioned, it is negative because the line slopes down to the right. So from the left to the right, it goes down, which means it's a negative slope. We can also find the slope of a line without a graph using the points on the line, using the coordinates of the points. So here, if we're doing that, we have to use the formula for finding the slope, which is m, which m represents slope, equals y2 minus y1 over x2 minus x1. So that means you have to name or label the points. So our first point are the ones. So we have x1, y1. So in this example, negative 5, 2, and negative 4, positive 4, negative 4, our x1 is negative 5, our y1 is positive 2. In our second pair, we have our x2 is positive 4 and our y2 is negative 4. So then I just plug those numbers into the formula. So m equals y2, I don't need to rewrite that actually. Where's my eraser gone? So let's plug it into the formula up here. So m equals y2, so our y2 is negative 4 minus our y1 is positive 2 over our x2 is positive 4 minus our x1 is negative 5. So 4 minus negative 5. Now if you're subtracting a negative number, don't forget to put that negative sign in there. Otherwise you're doing 4 subtract positive 5, and we don't have positive 5 as one of our coordinates. It's negative 5. So again, y2 is negative 4, so I put my negative 4 in there. Subtract, y1 is positive 2, so negative 4 take away 2. x2 is positive 4, and my x1 is negative 5, so 4 take away negative 5. Okay, so then I just do my calculations. So negative 4 take away negative 2. Using the integer rules, that's negative 4 plus negative 2, which will give me negative 6, over 4 minus negative 5, so it's just making the switches. 4 plus 5 is 9, so I end up with negative 6/9, which is negative 1/3. Okay, so same answer as when I use the graph. I get the same thing because I have the same points. So you can either use a graph or the formula. If you don't have a graph, don't draw one. Just use the formula. You don't need to draw a graph. Okay, so that was the end of lesson 4. So now we're getting started on lesson 5. And in lesson 5, we're getting more into geometry. So lesson 5, today we are hopefully going to deal with angles. So we're going to deal with angles that are created when lines intersect, and we're going to look at angles in a triangle. Okay, so beginning on page 3 of your lesson, lesson 5, there's information on straight angles and intersecting lines. So what a straight angle is and what happens when lines intersect. On page 4, there's more information and some examples. Page 5 is supporting question number 1, and on to page 6 as well. So take your time and remember, do the support questions and then check your answers at the end of the lesson. All right, so there are a few key words that you need to know for dealing with angles. First one, of course, is the word angle. So an angle is defined as the amount of turn around a common vertex. So vertex is the next word that you need to know, which is the point created by two line segments meeting. So the plural is vertices. So what that means, so if we look at these angles, these two line segments, line segment AB and line segment CB or BC, meet at a point. That point where they meet is called the vertex. Okay, so that's your vertex. The angle, okay, is the amount of turn around a common vertex. So that basically means how far apart those two lines are, the ends of those two line segments are. That will give us the angle. Okay, so angles on a straight line equal 180 degrees. So if we put two lines together, we can create a straight, did I say two lines? Two angles together, we can create sometimes a straight line. So if we have two angles that are together, so this angle A and angle B together create a straight line. So we have this straight line on the bottom, and we have the two angles A and B created on the top. So when we put those two angles together, they make up a straight line, and a straight line or a straight angle is 180 degrees. So angles around a point, so if we have one point where three angles meet, then we have the angles around that point add up to 360 degrees, which is basically a circle. So angles around a point always equal 360 degrees. So we have some special names for some of these angles. So supplementary and complementary angles. Two angles are supplementary when they add up to 180 degrees. They do not have to be next to each other. But if they add up to 180 degrees, they are supplementary angles. So here's one example of supplementary angles. The 60-degree angle and the 120-degree angle. 60 plus 120 equals 180 degrees. So even though these angles are not touching, they are still supplementary angles. In the next example, we have two angles that are touching. And together they create that straight line or that straight angle, which also equals 180 degrees. So we have the first angle, angle LMP, which is 120 degrees, 124 degrees, sorry. And then we have angle PMN, which we don't know. But because we know the measurement of one of those angles, we can figure out the measurement of the missing angle by subtracting from the total 180. So 180 take away 124 equals 50, where's my eraser? 56 degrees, not 60. 56 degrees. So angle X is 56 degrees. Okay, so if we know the measurement of one angle, we can figure out the measurement of the missing angle. Those are for supplementary angles. Two angles are complementary when they add up to 90 degrees. And again, they do not have to be next to each other. So these two angles here are complementary because 27 plus 63 equals 90. These two angles in this diagram are also complementary because you can see that this is a right angle and it's divided into two angles. So 35 plus x will give us 90. So if we want to find out what x is, what the missing angle is, all we have to do is subtract the measurement of the angle we already know, which is 35. So 90 take away 35 is 55 degrees. So angle x is 55 degrees. Okay, so if we know the measurement of one angle, we can figure out the measurement of the missing angle. So angles on one side of a straight line. So as I said, angles on one side of a straight line, on the same side of the straight line, always add up to 180 degrees. So if we know the measurement of one of those angles, we can easily figure out or calculate the measurement of the missing angle by subtracting from 180 degrees. So in this example, we have our straight line. It has to be a straight line, and both angles have to be on the same side of that straight line. So we know that we don't know what angle A is, but we know that if we subtract the measurement of the other angle, which is 45 degrees, from 180, we will figure out what the measurement of angle A is. So 180 take away 45 is 135 degrees. So angle A is 135 degrees. We can also do it if there are several angles on one side of the triangle and we're given several measurements. So in this case, we've got 4 angles on the same side of a straight line, which means that all 4 of those angles will add up to be 180 degrees. We know 3 of the angles. There's only one we don't know. So what we can do is add the measurements of the other angles. So 45 plus 39 plus 24, which will give us 108 degrees. And then we subtract 108 from 180, and that leaves us with 72. So angle B is 72 degrees. Okay. So those are angles created by straight lines. So what are vertically opposite angles? So when we have angles that are created by two lines intersecting, two straight lines intersecting, we end up with what's called vertical angles or vertically opposite angles. So here we have one line intersecting another line. So they make an X, basically. The angles that are opposite each other in that X are equal to each other. So angle A and angle A are equal, angle B and angle B are equal. They're called vertically opposite angles. You will also notice that angle A and angle B lie on a straight line. So the two lines that cross create what kind of angles? Supplementary angles. So on either side of the line we have supplementary angles. So that means that angle A plus angle B equals 180 degrees. So we have vertical angles, vertically opposite angles, and we also have supplementary angles. So we have two different types of angles created there. Okay, so let's do some practice with finding missing angle measurements. Okay, so the first one we've got our straight line. We've got two angles on the same side of the straight line. One of the angles is 80 degrees. The other angle, we don't know the measurement of it. So we know, though, that 80 plus the other angle will give us 180 degrees. So all we have to do is subtract. 180 degrees, take away 80 degrees, leaves us with 100 degrees. So that missing angle is 100 degrees. Now when you're writing angle measurements, make sure you use that little circle in the upper right hand corner of the measurement. That indicates degrees. If you want to, you can write out the word degrees, but it's easier just to use the symbol. Okay, number 2, we have our straight line. 2 angles same side of the straight line. One angle is 38 degrees, the other one we don't know. So again, 180 take away 38. We just subtract. 180 take away 38 leaves us with 42 degrees. Okay, let's find some missing vertical angles. So here in number 1 we've got 4 angles. Angle 1 is 106 degrees and angle 4 is 74 degrees. So I'm just going to write those in here, those measurements in here, so we can see where they are. Alright, so we've got angle 2 and angle 3 we don't know, but we do know angle 1 and 4, and we have lines that intersect at a point. So vertical angles and vertical angles are vertically opposite angles are equal. So that means that angle 1 is the same size as the angle opposite it, which is angle 3. So that means the angle 3 is 106 degrees. And angle 2 is opposite angle 4, which means that angle 2 is the same size as angle 4, which is 74 degrees. So I don't even have to do any calculations here. I just have to know the measurement of one of those angles, and I can find out the measurements of the other angles. Okay, number 2. We've got 4 angles again. Angle 3 is 108 degrees and angle 4 is 72 degrees. Okay, so I can find angles 1 and 2 by looking at opposite angles. So angle 3 is opposite angle 1, which means that they are equal. So angle 1 is also 108 degrees, and angle 2 and angle 4 are opposite, which means that angle 2 is also 72 degrees, just like angle 4. So again, no calculations needed there. Okay, so for number 3, I'm going to just scratch out the measurement for angle 4. So we've got one measurement here, 132 degrees for angle 1. So for angle 1, our measurement, the angle is 132 degrees. Angle 1 is opposite angle 3. So angle 3 is also 132 degrees. Now, I can still, even though I scratched out the measurement for angle 4, I don't even remember what it is, I can still figure out what the measurements for angles 2 and 4 are, because I have supplementary angles here. So if I look at this straight line, so the 2 angles on the right side of this straight line, angles 1 and angle 4, will add up to 180 degrees. So I can find out the measurement of angle 4 by subtracting 180 degrees, take away the measurement of angle 1, which is 132 degrees, leaves me with 48 degrees. So that means that angle 4 is 48 degrees. And if angle 4 is 48 degrees, then angle 2 is also 48 degrees, because they are vertically opposite. So in this case, even though I only knew measurement of one angle, I could still figure out the measurement of the missing 3 angles, because I know that vertically opposite angles are equal and supplementary angles add up to 180 degrees. Okay, so that brings us to key question 24. Find the measurements of the unknown angles in the following diagrams. So you've got straight line, angles created with straight lines, and then you also have some vertical angles. So find the measurements of the missing angles. Okay, so the next thing is angles and parallel lines. So angles that are created when parallel lines are crossed by a transversal. So on page 7 and page 8, support question 2 is on page 8 as well. So again, make sure you do the support question before you move on to the key question. Okay, so what are angles and parallel lines? So angles in parallel lines are angles that are created when two parallel lines are intersected by another line called a transversal. So the two parallel lines are this one and this one. And we know these are the parallel lines because they have these little arrows that point in the same direction that tell us that these lines are parallel. Those little lines tell us that these two parallel lines will go on forever and they will never ever touch. The line that crosses the two parallel lines is called a transversal. So when a transversal crosses the parallel lines, then we have 1, 2, 3, 4, 5, 6, 7, 8 angles that are created. These 8 angles have special relationships. So first of all, we've created alternate angles. Alternate angles are sometimes called Z angles, and they are equal. So when the transversal intersects, crosses, then we have angles that are created they make a Z basically. So the two angles that are inside the parallel lines, and they are on opposite sides of the transversal line. Those two angles have the same size. So angle A and angle A are equal. Okay? Each pair of alternate angles around the transversal are equal to each other. So there's 4 pairs of equal angles. So we saw angle A, so angle B, so this is a kind of a weird shaped Z, but there it is. They're inside the parallel lines and on opposite sides of the transversal. Same thing here. These those A and B, are alternate interior angles. We also have alternate exterior angles. So angle C and angle C, they're on the outside of the parallel lines and opposite sides of the transversal, and the same thing with angle D, angles D and D in this fourth diagram. They are again on the outside of the equal lines and opposite sides of the transversal. So those angles are equal. We also have corresponding angles, and sometimes these are called F angles. These are also equal. So the two angles that are inside the letter F basically, and so these angles are on the same side of the transversal. And they're either both obtuse or both acute. So obtuse angles are bigger angles, acute angles are smaller angles. And they are corresponding angles and they're equal in size. So find your transversal and then the angles that are on the same side of the transversal and the same side of the parallel line. So angles W, X, W are equal, X are equal, angles Y equal, and angles Z are also equal. And so those are your corresponding angles. Okay, and then we have co-interior angles, and these are sometimes called C angles. These ones are not equal. They add up to 180 degrees. So they're the angles that are on the inside of the parallel lines and the same side of the transversal. Okay. They are not, as I mentioned, equal. They add up to 180 degrees. So angle H and angle G together will equal 180 degrees. Okay, on the bottom diagram, angles I and J equal 180 degrees. Angles K and L, K plus L equal 180 degrees. And angles M plus N equal 180 degrees. So here you have an acute angle, so a small angle, and an obtuse angle, a larger angle. Okay, so let's do some practice finding missing angles. So here we have our parallel lines that are being crossed by a transversal. And we have 8 angles. Now we have the measurement of one angle. But because we know the measurement of that one angle, we can figure out the measurement of the other angles by just using what we know about angles. So what we just learned about alternate angles, corresponding angles, and co-interior angles, and vertical angles and supplementary angles. So we can use all of those properties of angles to figure out the missing angles, measurement of the missing angles. So angle 3, we said, is 82 degrees. The easiest way to figure out the other angles is to just use vertical angles. So if angle 3 is 82 degrees and angle 1 is opposite it, it's also 82 degrees. Okay, now angle 3, let's use a different color here, and angle 7, they make that F shape. They are alternate angles. So that tells me that angle 3 and angle 7 are the same. They're also, angle 7 is also 82 degrees. Now if angle 7 is 82 degrees, that means that angle 5, which is opposite, is also 82 degrees. So now I know the measurements of 4 of my angles altogether already. Okay, they're the same. So now I need to figure out the measurements of the other 4 angles. So if I look at my diagram again, I can see that angle 7 and angle 8 together make a straight line. So that means that angle 7 plus angle 8, angle 8 equals 180 degrees. So I can figure out what angle 8 is by subtracting the measurement of angle 7 from 180 degrees. So 180, take away 82 equals 178 degrees. No, sorry, 78 degrees, not 178 degrees. There we go. So angle 8 is 78 degrees. Is that right? Is my math right? No, it's not right. It should be 98 degrees, not 78 degrees. Okay, so that means that angle 8 and angle 6 are equal because they are opposite each other. So angle 6 is also 98 degrees. And angle 8, use purple, angle 8 and angle 4 are inside an F. If angle 8 is 98 degrees, sorry, angle 4 is also 98 degrees. And if angle 4 is 98 degrees, angle 2 is 98 degrees because they are vertical angles. So here now I have figured out all 8 or 7 missing angles, and if you look at them you can see that 4 of the angles are the same and the other 4 are the same. And that's again because of the properties of angles. So there will be, if you have 8 angles, 4 will have the same measurement and the other 4 will have the same measurement. You're going only to end up with 2 measurements for the angles. There's never going to be 3 or 4 different measurements if you're looking at missing angles on a using that are crossed by a transversal. Okay, so take your time when you're doing this. Pay attention to the measurements of your angles. Okay, that brings us to key question 25. Basically, you're going to do what we just did. You've got the measurement of one angle, and you're going to find out the measurements of the missing angles. In B, it looks a bit trickier because you've got a triangle there, but ignore the right side of that triangle. And then what you end up having is 2 parallel lines that are cut by a transversal. So you've got angle A that's inside and angle B that's outside. You've got a 60-degree angle here, so you should be able to figure out the two measurements of those two angles by using the angle properties. Okay, so now angles in a triangle. So on page 9 of your lesson and page 10, it talks about the relationships between angles in a triangle, and then we got sport question number 3 on the next 2 pages. Okay, so what is a triangle? We all know what a triangle is. It's a closed two-dimensional shape with 3 straight sides. The properties of a triangle. So a triangle has, we know, 3 sides, 3 vertices, and 3 angles. So it's got 3 sides, 1, 2, 3. I shouldn't do that because they're all different. And it's got 3 angles, 1, 2, 3, and it's got the 3 vertices. Okay, tri means 3. The sum of the 3 interior angles of a triangle is always 180 degrees. So angle Q plus angle P plus angle R equals 180 degrees. The sum of the length of 2 sides of a triangle is always greater than the length of the 3rd side. So we're not dealing with sides of triangles right now. A triangle with vertices P, Q, and R is denoted as triangle PQR. So we just use that. Just like for angles, we use the angle A symbol or angle A, B, C, whatever. For triangles, the same thing. We use a little triangle. The area, well, we're not worried about area right now. So there are different types of triangles. To classify triangles, according to their angles, we measure each of its interior angles. So we can have an acute triangle because the triangle has all acute angles, which means that the angles are all less than 90 degrees. We can have a right triangle because a right triangle has a right angle in it. So a right angle measures 90 degrees. And we can have an obtuse triangle because one of the angles is obtuse, which means it measures more than 90 degrees. We can also classify triangles by their sides. So we can have an equilateral triangle, which means that all of the sides of the triangle are the same length. An isosceles triangle, which means that 2 of the sides are equal, or a scalene triangle, no sides are equal. And we can also have triangles that are classified by sides and angles. So an acute equilateral triangle has all angles that are the same size. All angles that measure less than 90 degrees, and all sides are equal. A right isosceles triangle has a right angle and 2 sides that are equal, and an obtuse scalene triangle, one angle measures greater than 90 degrees and none of the sides are equal. Okay, so what are the angles of a triangle? The angles of a triangle is the space formed between 2 sides of a triangle. A triangle contains interior angles and exterior angles. So interior angles are the angles that are inside the triangle. So here's my triangle. So the interior angles are A, B, and C. The exterior angles are, when we extend the line, D, E, and F. So interior and exterior angles. How to find the angles of a triangle? Just a second. Okay, so how to find the angles of a triangle. To find the angles of a triangle, you need to know the following 3 properties about triangles. So the sum of the 3 interior angles of a triangle is equal to 180 degrees. So A on the inside plus B plus C equals 180 degrees. The exterior angle is equal to the sum of the 2 opposite and non-adjacent interior angles. So angle F let me get a different color, over here, is equal to A plus B. So interior, so the non-adjacent interior angles. So F outside, basically it's the two interior angles that are opposite F. For angle E, it's the two interior angles that are opposite E, which are A and C. And for D, it's the two interior angles that are opposite D, which are B and C. The measure of angles on a straight line, of course, is equal to 180 degrees. So if we look at these angles here, we can make our straight line right here. So angle E plus angle B is 180 degrees. And we can do that on all of the sides of the triangle. Okay, so calculate the size of the missing angle X in the triangle below. So here's X. We've got our other two sides, 84 and 43. So they're interior angles, so we know they add up to 180 degrees. So that means the angle X plus 84 degrees plus 43 degrees equals 180 degrees. So 84 plus 43 is 127. So X plus 127 equals 180. So we subtract 127 on both sides, just like solving the equation. So subtract, subtract. We're left with X, and X equals 53. So the missing angle is 53 degrees. Okay. What is an isosceles triangle? So an isosceles triangle is a triangle with two sides of equal length. We looked at it already. So two sides are the same side. And we know that they're the same size because they have these little marks on them that tell us those are the two equal sides. So in an isosceles triangle, the two sides that are the same are called the legs. The one that's not the same is called the base, basically the bottom of the triangle. Angles that are opposite the equal sides, so angle B and angle C, they're opposite the equal sides, are equal. So angle B and angle C have the same measurement. So here are some other examples of an isosceles triangle. So these are the sides that are the same. And so these are the angles that are the same. Another isosceles triangle, these are your sides that are the same. These are the angles that are the same. Here's another one. The lines aren't, they don't have the little lines to them, but they do have the measurements. So these are the sides that are the same. These are the angles that are the same. Okay, so how do we find the missing angle in a triangle? So for example, so we've got, these are not isosceles triangles, they're just regular triangles. So all we have to do is 180, take away 51, take away 40 equals, we'll call it X. There's no X up there, but anyway. So 180 take away 51 is 129. Take away 40 equals X, or I could just add 51 plus 41. 129 take away 40 is 89 equals X. Is that right? Let me check my math here now. 180 take away 51 take away 40. Yes. So angle X is 89 degrees. Okay, let's go down to this one. So number 3, we have the lines telling us that these two sides are equal. So it's an isosceles triangle. So because these are the sides that are equal, the angles opposite those sides are the ones that are the same size. So that means that this angle down here is 45. This angle is also 45 degrees. So we need to find out this one. So 180 take away 45, take away 45 equals 90 degrees. So this angle is 90 degrees. Okay, so that's how you find the measurements of the angles on the inside of a triangle. So basically, adding and subtracting, really. So key question 26, find the missing angles in the following triangles. So remember, angles add up to 180 degrees. So 33 plus 62 plus x will equal 180 degrees. So all you have to do is subtract. 180, take away 62, take away 33. Or you can add these two together and subtract from 180. This triangle, you have equal sides. Remember? Equal sides, equal angles. The next triangle, same thing. Equal sides, equal angles. Okay, don't get mixed up when you're trying to subtract. Make sure you get the sides marked correctly. Okay, so that's it for our class today. So when we meet on Thursday, we will finish up lesson 5. So try to get those key questions finished and send out to me for marking before our class on Thursday. Miigwech, and enjoy the rest of your day.